Welcome back everybody. This is a follow-up from my video of finding the domain of a function. In this video, I'm going to do one more example of a rational function where we have a fraction with a variable in the denominator. And in the previous video, I said to find the domain of a rational function like this, you have to set the bottom equal to 0 and exclude the x value you find when you solve the equation. So let's go ahead and do that. So we set the denominator equal to 0. We have x squared plus 2 is equal to 0. And we have x squared is equal to negative 2. Now notice how the denominator will never be 0. If you plug in a negative number or a positive number, here for x is going to be squared. Regardless of the x value, the denominator will never ever be equal to 0. Therefore, the domain of this rational function is going to be all real numbers. Now let's look at the domain of a square root function. To find the domain, you have to set the expression inside the radical greater than or equal to 0. The reason for that is because we can't take the square root of a negative number. Keep in mind also when you divide or multiply by a negative number, the inequalities signs get reversed. So in our first example here, we have x plus 5. So x plus 5 is greater than or equal to 0. And then subtracting 5 from each side, we're going to get x is greater than negative 5. X is greater than or equal to negative 5. Sorry. So in interval notation, this is going to look like this. In our example here, we have the cube root of 11 minus 7x. Now here's a thing with radicals with different indices. Before you solve any square root problem, it's pretty important to look at the index of the radical. If the index is an odd number, like cube root or fifth root, the domain of the function is going to always be all real numbers. However, if the index is an even number, like the square root, like this, or the fourth root, or the sixth root, to find the domain of the expression, you have to set the inside of the radical greater than or equal to 0. But for this example right here, since the index is an odd number, the domain is simply going to be all real numbers. Now in our last example here, we have root x squared plus x minus 6. Notice how we have a polynomial in here. So what we do is we have to think of two numbers that if you multiply, it's going to give us negative 6. And then if you add, we're going to get positive 1, which is the leading coefficient here. Two numbers I can think of for here are x minus 2 times x plus 3. And all that is greater than or equal to 0. So basically, x is equal to 2 and x is equal to negative 3. Now, for this type of function, we need to check the signs to see which is negative and which is positive. We have to choose random values off the number line for x, plug it into back this equation, and then write them on the number line, to see what we should include in our interval notation. So let's begin by putting out the number line right here. We have -3, which is right here, and then we have 2. -3 and 2. So we have to test values basically. Let's say in this section of the number line, let's say we choose -4. If we choose -4 and put it in here, we're gonna get -4 minus 2, which is -6. That's gonna give us negative. Plugging -4 in here, -4 plus 3 is gonna give us -1, which is still negative. Then if you multiply both signs, we're gonna get positive. Now between -3 and 2, the easiest number I can choose is 0. So 0 for x minus 2 is going to give us negative. And then 0 for x plus 3 is going to give me positive. And if you multiply both signs, we're going to get negative. Now choosing any number greater than 2, let's say 3. If we put 3 in here for x, we're going to get 3 minus 2, which is positive. And then 3 in here for x, we're going to get 3 plus 3, 6, which is still positive. And positive times positive is still going to give me positive. Now, as I said before, don't forget that -3 and -2 are included. So it's important to put a shaded circle here. And notice how the domain is valid from -infinity to 3, and then from 2 to infinity. We exclude this part because we can't have a negative number in the domain. We can't have a negative number in the radical. So in interval notation, this is going to be -infinity to -3 included union 2 included to infinity. So thanks for watching, everybody. Please don't forget to like this video and subscribe. Don't hesitate to leave a comment below in the comment section if you have any questions or concerns. I'll make sure to post more videos of examples of finding the domain of a function, especially under radicals, and a few other examples as well. And we'll see you next time.